All right, it should be live. Should be, mostly. And test it. All right, yeah, that's me. All right, so in business and such. So yeah, it's probably not for the faint of heart kind of physics. Um, Getting to something more fundamental in terms of just starting off with some idea of a universe and how it would evolve. And so what the primary function would be is somehow something going this way hits something going that way, and then you have a reaction. You have some sort of steady state that um, accounts for all of those impulses. So yes, I believe the universe is made of forces and not anything magical. There's no action at a distance that doesn't happen because something has to transmit the impulse. It has to hit it. So it has to make contact. And whether you think of a radio wave as, well, that's not a something. It's a something in the sense that something travels and takes time to travel. That sounds like a something. Some things take time to get from one place to another. A nothing, you imagine, could, just poof wherever it wanted to, and nothing. It can be nothing anywhere, any place, you would think. It's only a something that has to take time to get somewhere. So we kind of know the universe is really running on stuff that takes time to get where it's going. Nothing appears to travel anywhere for free or instantaneously. I don't think there's any experiments that demonstrate anything called an instantaneous, any, credible experiments. Um, so I was doing some thinking on that and, drawing some stuff, just forces and how you would preserve something like momentum, conserve it. And it also gets to the um, argument about how you create the perpetual motion engine and the fact that we can't use an analogy to it. I mean, I can't give you an analogy or an example in the real world of something that can behave exactly like these things behave. And the key feature is to find the key feature, to find out why. Why can't I make one of these out of bowling balls? Or why can't I make one out of, you know, materials? And the fact is because I can't duplicate the elemental function. I can't find the proton, the something that works like a proton. I can't find something in the real world, big world, that acts like an electron. I can't find something that has as its nature the function that creates charge. And so now we're sort of getting back to the website argument, where you have the two forces in the left turn, right turn, this turn, that turn. The idea that the two kinds of interactions are a reflection off of something. So something is there and the force hits it, gives it essentially motion this way, and the thing does the equal but opposite reaction and shoots a force going this way. Now it looks like this is a reflection, but technically it's not really. It's an absorption and an emission in opposite directions, equal and opposite. Um, so that's one interaction. This other interaction is this turn thing where the thing goes in this way and it comes out as energy in one of these, some perpendicular direction. Now it's only a half, it looks like less, quite obviously. It's only taking something and turning it, or exchanging, like a car accident, exchanging. And as I pointed out, the car accident would be, you'd much rather be in this car accident than this car accident. Um, and why is there a difference? And the difference has to do with this fundamental function. So I could make a perpetual motion machine if I could make a bowling ball that functioned like a proton or an electron. But I can't. So I can't make one. Only you can only make one out of these subatomic particles because only a proton has the properties of a proton. Just the rules. It's the way the universe works. So anyway, so that gets to this more fundamental argument. But I think before I go on to that, I will. Robin Evans left a comment. An interesting fellow. Very smart. But anyway, well read anyway. You could argue volumes of references. He's really, knows a lot of names. I've long forgotten. Anyway, so he says, "What's your opinion on the Lewis de Broglie theory?" So that's the Brom de Broglie, because he puts it down here. Quantum motion further developed by Brom de Broglie. Well, obviously, I have, as I've expressed, I have some substantial I have problems with de Broglie in the sense that he's the guy who came up with this fake of calling velocity a frequency. To be able to convert electrons into wavetons for the purpose of explaining their behavior. He took something that has a velocity, and so they could use the same equations. They turned velocity into a frequency. And that's a cheat. And it might be good if you need some expedience to make your math work, but it would make more sense just to concede you have to use a different equation for electrons, and you do the conversion without the metaphorical leap, the leap of presuming electrons to be the same as photons and trying to ascribe to them the same properties, when yes, their effects are similar, but as I pointed out, there's a big difference between how electrons and how photons behave, in the sense that photons have no field around them. They're not emanating a force field of any kind. They're not repulsive or attractive, and electrons are. And so the big difference between the interactions between photons and electrons is that electrons bounce off of each other's force, the field around them. They're repulsive. So like magnets, you can take two magnets with the same poles up, put them on a surface, and you can push one magnet anywhere you want to with the other magnet. As long as it doesn't flip over, they will not hit each other. And you'd have to shoot the magnet at a substantial speed to actually be able to get through that force quickly enough to actually hit the magnet, because the force will react and it will create more pressure between them before they ever hit. So electrons can glance off of each other. The closer I go, the more I deflect. The further I interact, the less I deflect. That's how electrons create the pattern in the double slit experiment, is they're deflecting. And that's why the pattern graduates. It does what the math is supposed to do, which is it has this very gradual light to dark pattern. It's because the electrons can do all of this fine little tiny bits of difference in their deflection, where a photon doesn't do that. Photons hit, and because of the rigidity of the electron's position, the electron can only move in certain ways. So if it hits here, it's going to move 3 degrees, or it's always going to come back. It's always going to come back the same way. So that's what's causing the averaging, and that's what's causing the bar pattern with photons, is that photons can't do this gradual impact thing. They have to hit, and when they hit, it's decided by the electron, and we have certain rules to its flexibility. So just like the standard orbits of inside the atom, of where the electrons can only exist in those positions, it can't exist somewhere in between. That rule is essentially revealing itself with photons in a sense, because when they go through the two slit, they're coming out at more specific angles. So like anywhere from 10 degrees to 15 degrees will end up being 12 degrees every time. So it doesn't matter which one, it's always 12 in that range. So photons are denied the flexibility of minor interaction. Well, one way to put it. Photons interact completely, and the result of the interaction is a complete angular. It's either 3 degrees or 6 degrees or 12 degrees or 24 degrees or whatever. So the big difference in the function. And so de Broglie essentially broke the idea that these are different objects and allowed quantum mechanics to play this game where they want to say an electron is the same as a, whatever they call it, bully ball or whatever the stupid carbon atom thing is, or a baseball or a soccer ball, as if the quantum mechanic rules are consistent for all of those things when they're not. Now, this also relates to the radar experiment, where again, they've taken a circumstance where they're using the same photons as visible light in the sense that they're electromagnetic spectrum, they're wavelengths, groups of little bits coming at a frequency. So it's still a kind of electromagnetic radiation. So it's very similar, let's just say. A radio wave is very similar to light, except the frequency change. It's the only distinction, substantial distinction. And yet they're saying these are quantum mechanical effects, right? These are effects. This is the one that really demonstrates another leap. So they've said, okay, there's a pattern that they can create, they can notice when these radio waves at a certain frequency go through these slits and they're going to interfere with each other. But the interference is a completely different kind of interference. It's a frequency interference, which means it's just related to the frequency. There is no interference in the fact that the photons actually the radio waves do go to all the locations. You just can't receive them anymore because they're jamming each other. And so you can understand that they should have known this isn't the same experiment because they're using photons, very tiny things, and they're putting through gigantic slits. So even if they use real slits, and they're not just two guns, but they use actual slits for microwaves, you can see they're big, giant slits. And we know that the quantum mechanical effect has to do with this little tiny slit because it has to do with forcing the photon to interact with the surface. That's the key to the small aperture. And it's just such an obvious key, right? I mean, I'm not straining credulity, am I? To suggest to you that the main feature of making an aperture smaller is that you will create a higher probability that the photon travels near a surface. And that's not an outrageous UFO kind of claim, right? And so clearly in radio waves, when you have big giant slits, only a tiny fraction of the radio waves will be going anywhere near the surfaces. So we shouldn't expect to get the same quantum mechanical effect because the quantum mechanical effect has to do with the surface, if you understand it that way. And clearly none of you do. I mean, none of the conventionalists think the small aperture has something to do with the surface and obliging a photon to travel near a surface. Even though there is such a thing as the single surface experiment that will also reflect the light. It'll create an interference pattern. It'll create bars. It's not obviously it's not interference. So don't let me confuse anyone by suggesting I think there's any such thing as interference, because I don't ever happening with photons. They don't interfere with each other or themselves. That this doesn't happen. They interact with electrons. So, but anyway, so I'm just saying that you can sort of see this. So once I established that this radio experiment is flawed, then maybe you'll understand that. Now think about the electron experiment and understand the flaw in their thinking. De Broglie is basically just converting a velocity into a frequency. Well, we know the frequency of the light changes how much the electron moves when a photon hits it, how aggressively it moves, and that would change the angle. So that all makes sense, that there'd be a relationship between where the photon ends up and the frequency of the light. And so when you convert the velocity of the electron, what you're basically saying is there's two factors that decide how, when two electrons are going to interact with each other or bounce off each other, there's two factors that that decide when two magnets are going to bounce off of each other. The thing that's going to decide where it ends up is how close it is, how close the interaction is, and how fast the thing is moving. So the faster it's moving, the less it's going to get deflected. The slower it's moving, the more it's going to get deflected, just like gravity in reverse. So we know those are the two variables. So we know why electrons are doing what they're doing. I mean, we can know it by that simple explanation. So is there anything else I have to say about de Broglie? So this part of de Broglie, okay, is de Broglie's theory to fix the Copenhagen problem. So in the two-slit experiment, the Copenhagen thing is basically the same as de Broglie, but the difference is Copenhagen is saying that it's this idea of terminating a wave function, whatever they call that. They have a word for that shit. Cancel, no. Collapse. So they have this idea that the photon doesn't have a position, it's not anywhere, and that it's only when you force the waves to collapse, that is, you decide this is the interaction point, that's when the thing becomes real. So it's unreal. It's not traveling through space by the normal rules of you go a speed and travel a distance, not obeying any of those rules. It's just nothing, something. And then it's a something when it hits, but it's not really hitting. When it's determined by some sort of, you put the screen in the way and the wave hits it, whatever that means. So some sort of nothing entity that the nothing particle has, it's created some sort of radar, and the radar will pick a point, and then the particle will arrive at the point, not traveling on the point. And de Broglie just changed that. So instead of having this wave collapse thing that implies you have to observe something to see it, that's sort of where they got the idiotic notion that nothing happens until we look for it. And that's sort of the Einstein counter argument. The moon is the moon. It doesn't go away when we're not looking. And so de Broglie is trying to fix that, Bohm. And so all they're doing is saying there's a particle, and it's basically a pilot wave theory that the particle is traveling on some mathematical geometry that basically does the same thing as the waves, except it just updates at certain periods in the path. So the electron or the photon doesn't travel any kind. So it certainly doesn't do the I don't have a position thing. So it's basically doing the I have a position, and I'm going to arrive over here, and it arrives there by doing this, to get there. It somehow updates its position and ends up at a location. Now, to me, it's the same. They're using the same math in the sense they're just doing this interference thing. They're just updating the location, more often, and creating bending points. So instead of establishing that the angle is created at the slit, at the point you leave the slit, you have got your final angle and you will go somewhere. So nobody is suggesting that. It's a little bit ironic, right? None of the conventional theories in physics, none of them, you have many worlds in Copenhagen and this de Broglie thing, and there's probably a few more, and none of them suggest that the photon, when it leaves the slit, is pointed in a direction and it goes there. So none of them think the photon leaves the slit with the decision of what angle it's at. I would argue that what's happening is that the photon travels through, it can interact with these electrons on the surface of material, and if it hits an electron that's inside the atom, closer to the shell, it might bend 6 degrees. If it hits one on the outside, it bends 3 degrees. And everything's a multiple of that. So you could say it's 6, 3, 6, and 9. So it can do 9 all at once, and then it can hit another electron and do another 3. And then it can hit another electron, be a 9er, that kind of thing. So it can, but that's what's creating the final angle. And so the angle is always going to be a multiple of 3. All right. But no one suggests that. No one suggests that the photon is done. All the interactions that decide where the photon will go happen between the slits. Once it leaves the slit, it's done interacting, and it's going to just travel a straight line to the destination. No one suggests that, which to me seems like the obvious answer. That seems like the first choice you would try to debunk or prove it can't be. And I certainly don't think there's any proof that can't be. So it seems rather amazing to me that I really am going back to, some sense of starting over and saying, well, wait a minute, I don't think you've really done this logic the right way. I mean, it's like the O.J. Simpson trial or something. The obvious first suspect is the ex-husband, right? I mean, that's just duh. And it's like none of the detectives, so if you were to do that, it would be like none of the detectives paying any attention to OJ. They're all looking for drug lords or, homeless people or some other kind of crap, and that would be, to me, logically nonsensical. You'd have to have a very good reason to exonerate the ex-husband before you would exclude him. And even if he wasn't physically capable of being present at the moment of the murder, you could still be saying, well, I'll see who he might have paid. It's such a strong first theory. And it seems a very strong first theory that the photon goes into the two slits. That's where the change takes place. When it goes out of the two slits, it's done changing and just ends up going where it's going. So anyway. All right, wait, why has no one commented yet? I don't know. People suck. Buckyball. Yeah, buckyballs. Okay. Were you molested by a wave as a child? Or maybe, I don't know. I'm sorry. Yeah, it just seemed, I don't know why it was intuitive to you, but I'm just saying, when I was in grammar school and I first heard this wacky photons are doing this and this, and I also knew that photons are the simplest thing in the universe. Okay, they're this little small thing. They can go in tiny, tiny little holes. They're so tiny. They're very tiny. And they always, like wherever you look at them, they're always going in straight lines. I mean, I understood a light bulb, right, as being rays of light coming off the light bulb, like the sun having little lines coming out of it. That was my understanding. Yes, there's little things flying out of it that are in a straight line. They're not doing this shit and this shit. So I'm just saying, if that's intuitive to you, fine. But to me, that molested my common sense. Anything in the universe doing this, you're going to have to explain to me, what does it have, a tail and fins? I mean, how does it do all that shit? How the fuck is it doing all this action? Where is it, where's the energy come from? Because that doesn't sound right. I mean, the idea that something shoots in a straight line, I can sort of get. But if I throw something in space, I don't expect it to do this. Does that make sense to you? You could throw a baseball and make it go up and down and then back up again, then back down again, then back up again. You can do that with a baseball? And even worse with the baseball, you may go up and down and do this at the same time, going side to side. You can throw a baseball like that? I sure as fuck couldn't. So yeah, I guess in a way, I was logically molested by this model of reality that to me sounded like absolute shit. And yes, so yeah, since I was a child, I thought that has to be bullshit. Nobody rational can believe that crap. All right, no, he just doesn't think shooting at one spot is a wave. Yeah, I just don't, it doesn't make any sense to every other, the photographic plate. I mean, it was, it's like the week before they're telling me photons are doing this. The week before they're showing me a photographic plate and that it's a little tiny dot and it's hitting in a little tiny location. How can it do that if it's doing this? Doesn't that mean it has to spread out? Doesn't make any frickin' sense. All right. All right. Oops. Yeah. But if you apply the wave equation, it's not much of an equation, okay? And number two, it's not a wave equation. The only thing in it is an angle, sine theta. It's an angle. There's no wave in the fucking equation. That requires the Huygens part. The Huygens part makes the sine theta angle. And it does that by creating the two waves. So the angle comes after they do Huygens. Huygens isn't in the math. Huygens is something they do before they do the math to say this is the cause of sine theta. But there's no wave in the equation. So this is how broken it is, physics, right? They call it the wave equation, and it's an angle equation. They call it the speed of light when it's the speed of force. I mean, it's just, they call it bent space when it can't be bent because there's 3 dimensions and bending doesn't work in 3 dimensions. Anyway, the wave equation to the single slit and the double slit, you get the same pattern. You don't get the same pattern in the results. So again, go look at the patterns. Go look at the electron experiment and you'll see beautiful gradation in the pattern. Light to dark, light to dark, light to dark, light to dark. Hundreds of degrees of softness. Then go look at the photon experiment and you'll see bar, 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 bar. No gradation at all, right? The math obviously doesn't predict the experiment in photons. Obviously, in my opinion, because the pattern doesn't have that subtlety the math says should be there. So you're not even getting that right. That's not pointing at fixed angles. Why isn't it? What do you think the wave equation, the intersecting waves, what do you think they create? They create points, okay? They call them nodes and they call them maxima, and they number them. And all the math is basically doing is saying multiply the number times the angle, and that's the location. That's all there is. It's just a multiple of the angle. Idiot. Jesus, fuck, what a cunt. Okay, that's not pointing at fixed angles. That's a partial Diffie, Q genius. Fuck you until dead, you useless cunt. I mean, really, just fuck you. I should just block him now, but I'll wait and see what else he says. Oh, it's obviously the fucking cowboy again. Ugh, what a waste of time. All right, and when I say the same pattern, I mean single slit and double slit patterns. Well, obviously the same pattern, I don't know how that could possibly, the double slit pattern is different than the single slit pattern. Oh, okay, so you're just clarifying that you know that. But I would say the point is electron pattern versus photon pattern. Same math, different optical result. Fucktard. All right. Complex math should not be required to explain physical phenomenon. Well, I don't necessarily agree that some of the math can't get very complicated, because you can have, it's like an electron, like the photons I'm talking about. You could argue that there can be many, to get my circle, to trap a photon, to trap energy inside of a atomic system. You could argue that there could be lots of ways to build that circle. You could go this way and over here and over here and over here and over here. And, Gaussian surface kind of nonsense. You could go all over the fucking place to get to your conclusion. And obviously, the math of deciding how you average all those possible paths can be narrowed by the fact of the geometry of the atom. So that means it can't take any path. It can only take specific paths. So that could be very complex math, because you can't just create anything. You have to put in a lot of variables that have to do with, it's a hexagon. Hexagons have different rules than octagons. So I don't necessarily agree. I know what you're saying. Some of the math is obtuse, if the word could be used. I mean, it just doesn't seem there's any connection between understanding what the math is doing and how it relates to what physically is happening in the universe. And there's no obvious connection between the math and a physical circumstance. And that's very dangerous math, in my opinion. All right. Sid, waves are explained with complex math. Well, they're not really complex. So again, you say a wave is complex. It's really not. Waves are averaging mechanisms. I mean, waves by their very nature go circular. Waves, they have tension, so that's why they go circular. They do lots of things by specific rules. So waves aren't that complicated, shithead. I mean, if you put a lot of waves in a system, it's going to be complicated. But the waves themselves are not that complicated. Wave math shouldn't be very complicated. No reason for wave math to be complicated. Let's see, Sid. Waves are explained with complex math, so waves don't exist, idiot. Yeah, clearly he didn't say that, but fine. It's not complex math. I mean, there's only four variables in the double slit experiment. It's not that many, right? Distance, frequency of the light, width of the opening, or the impediment in the double slit experiment where you change the variable. And yeah, that's it. 3 variables. All right. So fuck you. You didn't learn this in grammar school. You had some comments on your channel by Puro about speed of light, and you had a psychotic break with reality and became a science denier. Just absolute nonsense. I swear on my dead mother's blissful whatever afterlife that I have not rendered a false story. I protested in class, even in the sense that, I attempted to, I wasn't very good at articulating it, but I was just attempted to make the argument. What does this? What is that? Some new force? They probably just gave some field explanation, but clearly what's doing that? How does it do that? Was sort of my question. But anyway, it's fuck you. It's a real event in my introduction to physics that the first thing that I found that can't be true was that silly story about waving photons. To use your own joke, asshole. All right, so I'm just going to block him now. It's too rude. Too rude. Fuck you. Wasting more time making more fake accounts. I hope YouTube finally catches you and just blocks your IP eventually. You're a disgusting troll. Hi, Gary. Yes, useless comment. Nothing could be as useless as Gaylord's comments. Yes, it's the cowboy, so let's call him who he is. Anyway, I mean, he's obviously an obsessed psychotic, which makes him dangerous. I mean, I really should make a report of some kind, that I'm being harassed by some Texas lunatic, who works for the Public Works Department or something. It is disgusting. I mean, you just can't let it go. Just fuck off. Go find something else to do with your life. We obviously don't agree, cowboy. The end. But you're not making any kind of rational arguments here. You haven't defeated a single one of my points. You haven't explained how they're not true. Have you explained that the photon experiment looks just like the electron experiment? Have you explained where that proof is somewhere? No, you haven't. You haven't demonstrated anything I've said to be incorrect. It's so strange. All right, so let's see. So where will I jump to? So I finished the de Broglie thing, right? Yeah, pretty much killed that, right? I think I killed it. In a lot of ways, I killed it. But yes, I'm not a big fan. It's a cool name, de Broglie. Boehm. I think Boehm was kind of interesting looking. He was kind of like a big, tall Frankenstein looking like guy, I think. He's kind of interesting. But obviously, I just think it's just horseshit. I mean, it's like they thought this Copenhagen thing, where, oh, yeah, we have to perceive the world for the world to exist. Okay, they said, oh, that's too silly. And so they wanted to keep the same bullshit mathematics. And so they basically just said, okay, well, we'll come up with a new, not quite Huygens-y explanation. It's Huygens, but not Huygens. I mean, it's still dependent on Huygens. I mean, they're still arguing that it's wave interference. They're just arguing that it's this invisible wave that the photon travels on, and it only gets moved a little bit at a time by the waves. So it's the same wave interference. They're just saying that the bowling ball is flying on the waves and it just rolls, probabilistically like a pinball machine, like a pachinko machine. It bangs into the little sticks and ends up coming out the right pattern. It's just a rationalization for bad theory, bad fundamental theory. All right, now to see if I'm a little apprehensive just to get into this, this deeper layer where you start to try to figure out whether I'm arguing in a sense that the universe might just be these two colors of arrows, and there's always the same number of them everywhere. And all you can really do is change the colors of them. You can make a whole bunch of black ones over here and a whole bunch of red ones over here, but you can't really, you can make them at a frequency, but you can't change the fact that there's always an arrow in a location. There's always an arrow, and you're just changing its orientation, red or black. And so in a sense, the nuclear bomb is going off all around us in the sense that there's just as many arrows as if a nuclear bomb goes off. And the difference of a nuclear bomb is that a bunch of the arrows are at a frequency, and that's it. So they have patterns: red, black, red, black, red, black, red, black. So frequency would always be made of, so a photon, a string of light, a ray of light, wouldn't have empty spots in it. It wouldn't be. It just means that there's a black one, and then there's two reds, and then there's a black one, then there's two reds, and then there's a black one, there's two reds. There'd be no. So I'm almost arguing that frequency of photons would be quantized. That might be detectable. That there is no. That on a Planck scale, there's a certain point where you can't make the distance infinitely smaller. You can't just shave a little infinite amount of distance off the frequency. The frequency, in a sense, comes in clumps. But anyway, so this is obviously, it's an unnecessary part of the theory. It's just a part that I find sometimes interesting to go and try to think about what an even simpler, even going simpler than the 4 little rules, and go back to something even simpler and seeing if you can develop the 4 rules from that even simpler mechanical system. And it's a good thing to do just because it keeps you aware of this idea of conservation of momentum and stuff. All right, so maybe I will draw. Maybe I'll show at least what I've drawn. I don't know if I can explain it. See, the point would be is to have some of you maybe take this as a puzzle to solve and also think about it. But that's probably not going to happen. So there's might be a little point in this video proceeding for the next few minutes, unless somebody comments in some relevant way and that becomes interesting. But that seems a silly expectation. So we won't bother with that. All right, so let me change the camera. I thought I left it visible over here. I must have moved this. Yeah, I did. Okay, that's not right. That's like sound settings. That's not right. Ooh, what did I just do? Oh, somehow I made a new document. Oh, I don't need the sound settings. That's not what I'm looking for. Oh, here it is down here. Oh, bastard hiding. All right, so this takes a second. Sorry. Gotta switch cameras. It takes it a second to get up to speed. Oh, it wasn't. Yeah, well, it's about a second. It didn't take too long. All right, so we will make this bigger. Ooh. Hopefully without too much trouble. All right. So what I was thinking, all right, this is just a sloppy version of it. So these pointy things are just imagine those are arrows, okay, and that's just a force moving. So that's a little particle moving at a constant speed, the speed of light. And just for the sake of making this easier to understand, I decided, okay, put them at a standard frequency. So they're just coming at a frequency, like say 1 second apart or whatever, in a little mass. And they're hitting for each other. So there's a stream of force on one side and a stream of force on the other side, and they're balanced. That is, the same amount of force is coming at the same frequency on both sides. So that's sort of your starting point. And you think about what happens if they interact. So there's this middle bit, that's the interaction. And the thought is, it's not drawn very well because these arrows on one side look smaller. So obviously this is just signifying the reflective moment. So this side hits, say, this side, and you have your first reflection. So the arrows were going this way, and then they reflect back this way. And so then you get to kind of like the stage 2 situation. So anyway, so what you observe is, which you can't see here, is imagine this frequency is a little wider, and imagine this one's a little narrower. But the trick would be the distance of this, the time it would take this to come back is it's going to be exactly half of this distance. At least that's what I predict. So this stuff in the middle now, it's going to be kind of permanent. This stuff will keep coming in, but these same arrows are going to keep going back and forth here in the middle. That this is 1/2 the frequency of the forces coming in. All right, and so then the second attempt was to think about what happens if I add a force arrow this way. And you have to think that it's still within the same confines as these. So even though there's no visible room for another arrow, just imagine there's another arrow within the same space that these 4 come in. But anyway, so what does that arrow do? Well, there's no, it's extra force, more than the 4 that got consumed here. So this was perfectly balanced. So that extra arrow doesn't have anything to hit because all the force that's coming in gets hit by these arrows that already exist. So this new arrow heads for the next bunch of force, and it's going to hit one of those arrows. So here's the 4 coming in that are going to be the same amount of force as these 4, and this new arrow is going to end up going half the distance, okay, because they're traveling the same speed. So it's obviously it's going to get halfway and it's going to hit one of these arrows. And now it's going to reverse and do the same going back and forth thing. Now, whether I accounted for that, I don't know in this drawing. Okay, so it gets too simple. I mean, it's cut to shorthand for me for the rest of it. So I think I'll just get a new piece of paper and attempt to argue from that point. So it's really just following the time evolution and what happens to this stuff in the middle. So the idea is now all the let's see if we can just draw the middle arrows this way at a point of impact. And there's the other force arrows are coming at their frequency. So they're here coming. And then these are the other ones coming this way. And so what I did was add a new one that's going to essentially kill one of these. So one of these is not going to go, it's not going to make it to this location where it hits these and then they reverse. So obviously these are reversing and ends up going back to here by the time this wave shows up. So I think you might be able to follow that, maybe. So I'll do the one killed in red. So I added another arrow. He's going to hit this arrow. Okay, and he's going to hit it. If he came at the same time as this, so if I added it and he went at the same frequency as this one, he would hit it at half the distance away. So we'll use that. I don't know if I did that in my analogy. So I'm just going to I'm going to draw it down here just to keep it separate so it doesn't get confusing. So we added a fifth arrow, and we know that it doesn't have any force to hit at this row. So this is where the row stopped. This is where this one hit this row. Now the trick is when these reverse, all right, that takes a certain amount of distance, and it's half the distance of the frequency. So this one's going to be doing the same reversing. And I lost the tip to the pen. So anyway, so these are all reversing, and this one's going to do the same reversing thing. He's just doing it later than these do. So when these things are here, when these bounce back, this one is starting to go back. So when these end up going back this way again after hitting this force, this one starts meeting them here. So it'll end up being here when these end up being here. And now, so essentially when these are going to reverse, this one's already heading in that direction. So you'll have 4 arrows. Those 4 arrows come back. That's this distance here. So this one reverses when it hits this one. So it hits this one at this location. It reverses in the same amount of time it takes this to go back this way. So the full trip, when this went in this distance, these went this way. Now this one reverses. These are going to be coming up to the impact point. So the point would be is now these are all going to reverse this way because they're going to hit these 3. So 3 of the arrows are going to hit here, these 3, no problem. But we have one arrow, this arrow is already used up. This one already went that way, it's gone. So then the replacement is this one, and it's already going in the right direction. So in a sense, you're just going to replace this extra one again. And so essentially all that's going to happen is the exact same thing that happened the first time. This absence of chair to sit in means this arrow, let's say, is now going to be the red arrow, is going to keep going because there's no arrow to hit it. This arrow is essentially going to take its place as the reflected arrow. So 4 arrows are going to go this way and hit this force again. So this line always stays consistent, where this line always ends up with one element pushing this way. So the point is that's perfect conservation in a sense, right? So you had a simple circumstance where you had force going in two directions. You added one little bit of blue's running out. It's running out substantially. So you have the simple circumstance where you have two forces, and then you add one little bit of force. And even though the stuff's going back and forth, that one little bit will always keep showing up over here as one little bit too much. So if you were to draw a picture of your solution, it means you've kind of created something that had a shape like this, the stuff moving back and forth. And now its shape is got this little bulge in it that's kind of strange. It's added volume. So, and technically it is an extra force, an extra bit, and it's always going to be volume in that direction. So anyway, that at least it explains conservation. I mean, it illustrates the conservation. That you'd think that this force would just get lost in the back and forth. Oh, sorry. Back to the bulge picture. Yeah. So obviously this thing, the stuff that was just blue going back and forth, this stuff now has a new shape, and the shape stays permanent. So even though it looks like stuff just going back and forth, there's always that extra bit going this way, created from the first little bit you added. So you added it going this way. It doesn't have any representation coming back, and it always keeps showing up again going forward. I think that's the way it will work. So if somebody can say that's not the way it'll work, it'll be interesting. All right. Now the other thing is on a different piece of paper, apparently. Yeah, even drew it here. Anyway, all right. So this is back to the perpetual motion engine and what I was talking about. But let's just see if there's comments first, so I won't change subjects without checking and see if there's anybody saying anything. Oh, I can't see through the image. It's strange. I don't know why exactly you can't. But you can't. Hey, there's David. Weird. Bully. It's probably another fake name. Oh, it is a fake name. Amazing. I mean, it's just so trolly. He just steals other people's names. I mean, it's just such a low character human being. All right. Who is informed on physics, Piro or Hathaway? Well, I'd say Hathaway is more careful than Piro, and certainly more thorough, and more worried about saying something incorrect or being inaccurate. Piro just spouts shit. I mean, he spouted that shit about we were arguing about lensing, and he said none of the lensing images show individual stars, like in a galaxy. So like there's a galaxy being lensed, and he argued that none of the lensing images show any of the individual stars. Complete bullshit. I mean, almost every single one of them, you can make out individual stars in the galaxy that's getting lensed. I mean, it's just, so Piro just, he just shoots shit. Hathaway, much more careful. More informed, probably Hathaway. Yeah, well, Hathaway has I think he has. I think he has, yeah. He's just not as sloppy, and I think he has a more. Is less religious than Piro, quite obviously. I mean, he just doesn't buy any kind of loop-de-doo. You got to show him some kind of evidence. Anyway, I think Amendment 1 hosted a live physics discussion with Hathaway. Well, I think we attempted something, and I don't think it went anywhere. So this is the fake name. Piro studied physics in college for 3 years at Berkeley. Well, that's a lie. Okay, physics. He was getting a philosophy degree, and he took a couple of semesters of physics. He didn't take 3 years of physics. You're just a fool. Whereas Hathaway has a math degree, yes, and engineering experience. So I'd say Piro is better informed. Well, I'd say you're an idiot, but they're both more informed than Stoner Simpson here. Yeah, whatever that means. So again, you haven't defeated a single argument I've made. You can't answer the simple questions I put in the question videos. You can't handle the simplest of tasks, and you're talking about other people's mental disabilities when you're clearly the one with the weak argument. You can only insult my hair or my appearance or some other bullshit. You can't make any fucking arguments. Jeez, useless piece of shit. All right. I don't remember what specific physics topics they talked about exactly, but Hathaway became very agitated towards the end of the hangout and rage quit. I don't know if he did or I did, but yeah, it was impossible. We can't communicate. you know, um, it's just unfortunate, but it just doesn't work. Carol believes anything. Hathaway believes nothing. Well, that's probably the best simple way to say it. Hathaway is a little bit brain dead in the sense that I don't know what to say about it. I mean, he'll deny the existence of sentience as a real thing, and then accept a whole concept of particles spinning or something, for which there's no evidence, realistically. Anyway, graph science doesn't do drugs. Well, that's true. I mean, I do drugs, but I don't do ones that fuck your brain up. I do ones that make your brain work better, like caffeine and nicotine. I do good drugs, good brain drugs. I don't do bad brain drugs. I don't do, get a boner drug. I don't need get a boner drug. I don't need, whatever it is. Just put your brain on slow motion, time dilate your brain, on pot. I mean, it's very nice to be time dilated and forget what you are and who you are and where you are and all that shit, but it's no way to live your life. And you just end up getting the problem is it's like candy or something. I mean, you just don't want to get a tooth for it. And so if you get too attached to being stoned, then you're never going to be useless. You're never going to be useful for the rest of your life. It just doesn't make for clear thinking. It really doesn't. And it almost doesn't make for clear thinking in a strange way, in the sense that it makes you too perceptive. It makes you way too distractible. You see too much. So you can't concentrate on any one thing. It's like you're looking at a paragraph and you just keep seeing the one word. You just can't see the rest of the words. You just, that one word is so cool. That's how I experienced it anyway. It's like it was too much information. So you couldn't do anything with the information because it was too much information. Couldn't process it. Couldn't make my brain absorb all the stuff the stimulus was too much stimulus. I couldn't, somebody's rubbing my feet at the same time as they're tickling my arm or something. It's just too many things happening at the same time for me to process them. But anyway, I really don't want to get into conversation about fucking idiotic drugs. Terrible dead end. All right, so back to the theory of perpetual motion. So the idea would be, this is the idea. You have these little functioning bits. And I'm trying to think of a way of making one of these machines out of real matter and how it's just not really possible. But anyway, the idea would be is that the two red bits, the protons, are attracted to each other. Are repelled from each other. The two black bits are repelling from each other, and vice versa, the other way around. So the black bit's attracted to the red bit's attracted to the black bit. And so this thing gets held in tension. So this shape is a very viable shape, theoretically. And the idea is that you're injecting force into this shape. So the thing that's holding the tension, thing that creates the tension, is the fact that there's these little black bits, okay, that reflect off of electrons. So they're basically bounced off the electron, the proton turns at a 90-degree angle. So the proton makes the little bit, okay, do this. Okay, it just makes it do a 90-degree angle. I don't want to draw it too big, but and so the black bit will end up going from one electron through the proton to the other electron, back into the proton to the electron. So it just keeps trapping the little black bit. So if a little black ping pong ball gets in here, it gets stuck in here. It just keeps going back and forth, back and forth, back and forth. Now, the idea, so this is basically, just to add, this is basically what a helium nucleus could, in realistic theory, look like. In the sense that it's a neutron, which is a proton and an electron, and a proton and an electron. So that's basically the components of the helium nucleus. So anyway, something like that anyway. For some reason I'm saying, no, there's two neutrons and a proton. Two neutrons and two protons, well, whatever. Whatever the superfluous bits, forget it. There might be some. I don't know. Can't remember. Anyway, yeah, should get that straight. But no, this is the hydrogen atom. Yeah. Could be a hydrogen atom. Yeah. Okay. So never mind. But anyway, doesn't really matter. Point is this is the shape that does the magic. So the argument is, so you could sort of imagine, so let's just follow this along. So say if there is this black bit doing this thing. So the idea is it only reflects, it's doing, this reflection is a 180 degree. This is a head-on collision. So this reflection is basically, there's something, as I was just doing before, the arrow is moving inside the little electron, and it's a head-on collision. So the electron will get a momentum this way, and this other piece of force will go this way. So that's what's going to happen in the interaction. So, but it's a head-on collision. Now, this reaction is just a 90-degree turn. So that's this tangential reaction, interaction, where you just convert this 90 degrees. There's no head-on involved. So it's obviously a less energetic. Oh, shit. Gotta remember that. Okay, so I'm just trying to point out that the electron interaction is a head-on collision. The proton interaction is half of that in terms of an energy experience. So all that's happening is something is changing its direction this much, where in the other case, the change in direction is a full reversal of direction. So that's what the 180 and 90 degrees sort of thing means. So it's obviously a difference in energy. So you're getting a full hit this way, and you're only taking a half hit this way. So in a sense, there's this obvious disproportion. So there's more energy going this way than there is energy going this way or this way. And then the added feature is that you got to understand that this electron is held in tension with this proton. So as the electron travels away from the proton, if it goes this way, it's in a sense going to be pulled by the proton back this way. So now this energy that was going this way is going to essentially get converted to energy going forward. And likewise, when it's happening at this other end, when this proton moves in this direction, its attraction to the electron is going to tend to bring it back in this direction. So it's obviously it can't do it to that extreme, but the point is so this proton is going to wobble, on some curve like this, and these electrons are going to move in this kind of way up. And the argument is, by this mechanism, there's more energy going this way than there is energy going this way, presuming you have more force bouncing back this way than you have bouncing back and forth this way. So the idea would be that you collect the force somehow, okay, by extra force hitting this, it injects into here more ping pong balls. And the trick also would be is these protons would be in a line with each other. And therefore, if you had extra force coming in here, it would interact with this proton, and it would never hit this proton as it interacted with this one. So this proton would get hit by less force, which is sort of interesting. You know, in the sense that you could be filling the energy by some sort of conversion that takes energy in, say, this direction, which has a component in this way, right? I mean, this direction has a component this way and this way. So it has a component in the right direction, and then converting that into this direction, which would be trapping it. So how exactly more little ping pong balls, you know, little bits of black energy get trapped in here? I don't have a perfect theory for that, beyond the obvious that it's sort of easy to get to hit these electrons, and you can imagine them bouncing back and forth and getting trapped, depending on the shape of the electron. But regardless, the idea would be if more force hits from this side, it'll fill this part. It won't fill this part. And so this side gets more energy in it, and therefore the whole thing moves this way. Yeah, it's a little perpetual engine. So the trick is, though, is that there's nothing on Earth that can do this 90-degree turn thing as something where you'd say it's only half the energy. Because for us to do a 90-degree turn, we have to hit something, okay? And that's pushing us all through the turn. So there's a lot more energy involved because it has to come in and let's see how to draw this. You know, it comes in and it has to turn to go this way. And that essentially means that if it hits something, say a point, the problem is also is that it's on the smallest scale. This is a head-on collision. It's not really hitting a slope. It's hitting one object, and it's sort of like the head-on collision problem. It's really just having a head-on collision with this one element. And so you're back to the same problem where you're not really doing a half energy move. You're not really just turning something another direction. You're not exchanging the directions. So there's no simple way to duplicate that. Say if I put a spring on say if I used real ball bearings for this and springs, let's see, I'm trying to think of how I could duplicate it. You could sort of understand that if this was loaded with a spring, the spring would have to be in this direction. And so all the energy would convert into this ball moving this direction and compressing the string in this direction. So it would add up to the same amount of energy. But that's not what a proton's doing. It's just exchanging a piece of energy going this way for a piece going that way. And that's only a 90-degree turn, like stated. It's obviously less energy to turn something 90 degrees than it is to turn something 180 degrees. All right. I think that's consistent. So yeah, that was probably enough of that. So that wasn't so bad. But really, it's stuff you do have to draw out, and so that's part of the problem with some of this stuff. But I mean, that's just something I was working on. Is this you have to go from this simplest idea and try to convert it into this little middle section actually starting to move. So I mean, I've made it misshape consistently, but can I make it move? And we're sort of heading there, but so I haven't connected those two. They're big leaps in a different sense of the universe being more complex in one image than the other image. Quite obviously, I guess. I mean, the helium nucleus or hydrogen atom is a lot more complex than the elemental particles that make up force in the universe. The elemental bits. I guess I don't need to. I can throw this over here. What the hell? And we'll just change the camera. And don't know if we need to do that either, but we'll do it just to clean things up, and we'll see if the commenters have anything. And if not, I'll just editorialize on something else. And that'll be it. I smoke 2 joints in the morning. Well, that seems like an awful lot of pot to me because, I mean, when I was a kid, you could do a joint between you and a friend, and this was just crappy weed, back in the 70s. And you get pretty stoned. And the weed now is so much more potent. I just don't know how it could take you 2 joints to get somewhere. I mean, if I smoke 2 joints of pot, current marijuana, I just don't understand how. I mean, I would be unconscious. I just don't see how that could work. I smoke 2 joints at night. I smoke 2 joints in the afternoon. Whatever. It makes me feel all right. Smoke 2 joints before I smoke 2 joints. Okay, just a waste of time. More cowboy crap. Just keeps making accounts and doing this shit. Just such a horrible waste. So, sorry. I shouldn't have even read the comment. I should have read the screen name and just said, forget it. Wasted time. I mean, it really is obnoxious. I mean, I that I can't just tell somebody to leave me alone and they'll leave me alone. It's just insane. That's why I want, like I said, after I'm dead and I'm proven right, I want the world to go find this fucker and beat the shit out of him. It's just disgusting behavior. Why should anybody be able to do this crap? It's fucking stalking harassment. I mean, if he's making some sort of honest argument, I just want to make a screen name. I just want to make an honest argument. And then actually made an honest argument. I got no objection harassing me with something like a fact. But, stealing dead people's names and identities and, just talking shit is just such a waste. I already referenced the complete uselessness that I didn't see. There was nothing in that comment stream worthy of paying any attention. I did record it just because I said, I better capture that just in case somebody said something intelligent. But there was nothing there. It was crap. Stupid, idiotic comments about my hair and some other crap. I mean, it was just crap. Yeah, it's over here unsaved. Let's see. So it's your hair is stuck in the queen days, whatever the hell that means. I mean, it's just bizarre. So this guy thinks that nobody has long hair anymore or something. Oh, I don't think that's true, weirdo. Now, maybe you're bald and you have a skinhead. That's fine. That's your bullshit. It's just the joke is that I've never had a woman tell me, cut your hair. Ever. So why would I listen to you when no woman has ever complained, ever? They love my hair. So if women love my hair, why would I do anything to change it? Oh, that's right. It would be stupid to do anything to change it. Oh, God, so stupid. So this was another cowboy comment, right? The Smash Mouth's Greatest Hits 2 CD combo pack. So that's really important shit to see. Let's see. Research announced that they found the ghost particle this week. What? Yeah, I'm afraid not. Whatever that is, I don't think they found anything. All right, so So you debate someone's comments, so you delete someone's comments because you disagree with their opinion, question mark. LOL. So I already responded to this. Like, obviously, I don't delete people's comments for that reason. I delete their comments because they can't manage to make a civil argument. I haven't gone to their house and shit in their living room. Why should they be allowed to come here and shit? They want to knock on my door and say, I'm a Jehovah Witness. Can I talk to you? I'll let them talk. But that's not what they're doing. If the Jehovah Witnesses showed up at your house and started, pissing on your door and, farting in your direction and all that kind of shit, why wouldn't you just close your door? Say, fuck off, asshole. I mean, you people are so clueless. You don't make a counter argument. You just insult. You don't have an argument. All right. So Sid said, it wasn't an opinion, it was a troll comment. Have a good one. Whatever, photons are caught in 90-degree angles inside the atom, then why do we see spirals when they're released in the LHC? Where? You go ahead, show me this picture of the spiraling photon. Why don't you show me a picture of a photon? I'd be really interested. You have a picture of a photon spiraling? Yeah, show me that picture. Not a chance in fucking hell that the LHC has ever seen. An LHC shoots protons. You know the difference between a proton and a photon? Well, yeah, I know it sounds a little bit like. Photons don't spiral anywhere. All right, I mean, Jesus Christ. It sounds like minute, but to me, the photon and its properties sounds like minutes, but to me, the photon and its properties are fundamental. Yeah, it doesn't have many properties. It moves in a straight line from point A to point B at the speed of light. It just doesn't do anything else. And point A and point B are always an electron. I just think CW and CCW axial spins make more sense than blue and red properties. Well, whatever. The blue and red properties aren't. The axial spins will do you nothing, all right, in terms of creating a decipherable force in 3 dimensions, is all I'm saying. All I could change what a photon was, whether it hits an electron or not, simply by changing the orientation of the impact, changing the dimensional angle I hit the electron at. I just don't think that's realistically the way it works. I don't unphoton a photon by merely moving my target into some other angle. All right. LHC shows effects of the photon crashes. It doesn't do any such thing. So I don't know where you get that from. I mean, it really doesn't show photon crashes. It just doesn't. Yeah, it really doesn't. Unless you consider photon crashes like 1 million photon crashes or something. I mean, it shows electrons that have been pushed by an awful lot of photons to start moving very fast. But anyway, the whole XXI century physics is wrong because just one 1915 general relativity assumption. Well, I don't think that's the only reason why it's wrong. I mean, there's 2 catastrophes. General relativity is one catastrophe, but quantum mechanics is the other catastrophe. They're both catastrophically silly theories. All right. Expand space, not curves geometrically. Expanding space or contracting space, in my opinion, is just as silly. I mean, and there's no evidence that works anywhere else. I mean, you're saying you have one thing, gravity, created by some notion that space expands and contracts, and that somehow planets can feel the space contracting. Oh, there's less empty space. The empty space is emptier over on this side than it is on this side. Yes, the empty space is emptier over there, so I must fill the empty void in the empty. You know, the bucket is emptier than just empty. It's double empty. I mean, you don't think that's kind of silly? All right. So he says something to somebody. See that an atom, stars, and galaxies which can illuminate matter in nucleuses. So again, I don't think galaxies are collecting matter. They're barfing matter. They're losing it. It's their center is falling apart. It doesn't feel like scrolling. Yes, well, again, it's not like I didn't feel like it. I just didn't realize I had to hit the stupid blue button. Because something gives you the fuzzies doesn't mean it's true. Because you can write a sentence like that doesn't mean it means anything like an argument. Oh, because you have a brain doesn't mean you can think. I mean, I can say that, I mean, it doesn't really, it's not a specific enough insult to mean anything. All right, wish to smoke now as well, but going to work. Frowny face, not smoking. No, it's smoking and work after, I guess he was talking about pot, of course. Have to wait till first break at 10. Smokes at work, I guess. Are you talking to John? So, I mean, there's a whole weird old conversation. Well, anyway, enough of this. There really wasn't anything interesting. I didn't think. So there obviously was more than I thought. But, the galactic talk just doesn't interest me too much. The small universe is the only universe. I mean, does somebody really have a counter argument to that? That somehow the big universe has really got some sort of property that doesn't originate in the small universe, that it's all small universe. There is no big universe, really. There's just the little universe. It's the only one that really counts, the only one that's really doing anything. I mean, there's no real me. There's a collection of cells that make me, and that's it. The cells are the me. I'm not doing anything. They're doing it. What am I looking for here? I don't know. I guess I'm looking for the chat window. That looks like it. All right, let's see what kind of dumbass remarks there are. Okay, hello again, Gary. Many viewers were still coming. Oh, we already did that. Ghost particle. No, we already did that. You mentioned that photons may stick together. Again, I don't want to, I guess I should have to create some sort of mechanism to get to the part where I haven't really developed a theory on the subject. I'm just speculating on how things probably are, could be, or something like that. And it really doesn't have anything to do with the fundamental theory, except, obviously it's good to answer as many questions as possible, but they're not really important. I don't need to explain what an electron is to have a competing theory with the current model, because their model is silly. But anyway. But yes, force is compressed and sticks and creates the clumps that are matter bits, which would be the electron and the proton. To form the electron, do you think perhaps photons are not spherical? I think the geometry of the fundamental universe is likely not spherical, because I don't think their spheres have any function when you get to this little bit world. So just as I pointed out before, a square functions the same way, like as a circle, in terms of you can get trapped in a square just as easy as you can get trapped in a circle. So circles are what the big things do because the pressure keeps cutting the edges off. But the circles are all the least. They're all got little flat edges to them. There's no real circles in reality. And that's why there's no resolution to pi. Is because, I think the real geometry starts with straight lines. And there are no curves, are an illusion of a lack of resolution. If you had better resolution, if you could see deeper and deeper and deeper, you'd see it eventually turn into straight lines. Like the Earth traveling around the sun doesn't really, I don't think, move in straight, in a round orbit. It does a little, for Planck constants of distance, it does little lines of movement. The little bits inside of it are moving in straight lines, and the little bits add up to that curved line. The net product is the curve, but the curve, like a Etch-a-Sketch, is just made out of straight lines. All right, anyway, aren't photons like discs or frisbees or coins? I don't think so. At one time, I was figuring that they had to be something shaped because I had to explain polarization, but, the polarizing filters. But the analogy to the jail bar thing is too zoomed in an analogy, because the polarization I'm thinking now isn't have anything to do with the shape of the photon itself, the little force bit. It doesn't have anything to do with the force bit shape. It has to do with the alignment. So the bits are a little bit out of alignment. That's the polarization. And when they're perfectly in alignment, then it's called circularly polarized, ironically. But yes, so I don't think photons need to have a shape. They could be arrows, they could be triangles, could be pyramids, could be squares, could be lots of things. I'm not saying they don't have a shape. I'm just saying at present, I don't need to give them one. Yeah. Sorry, I mean proton crashes. Okay. Yes, that's what the LHC does, proton crashes. Axial spin would allow a photon to act like a pool ball. We already did this crap. In one instance, no spin, but like a spinning top in another circumstance. Shit, it's just going to keep dragging this crap up like it needs to. The point is that you can't quantize spin, in my opinion, usefully. So photons would end up having variable properties, and I don't think there's really any evidence of that. And I don't think there's any, it just doesn't serve any function. I don't see what good it would do. We already know the variables of frequency as being the important thing. And so what do you need spin on a photon for? What does spin on a photon accomplish? What do I need it for? What phenomenon needs to be explained by spin? Thanks for rechecking those comments on the earlier chat. Oh, okay. Totally agree with you that the current model is crap. Yeah, I mean, I wish I could just have two separate channels. In one channel, you just argue how we don't need a competing model, but we can criticize the current model as being under-evidenced. Just way too weak evidence for too hard a conclusion. They're making all kinds of statements about what is, and they're making them based on shreds of evidence, just tiny pieces of evidence. And they're just jumping the evidence. But clearly, I would also argue that having a competing theory that unifies everything much simpler really seals the deal. I mean, it double proves them wrong, obviously. The fact that there's a much simpler explanation that explains more. So it's not only simpler, it unifies, which they can't do. Let's see, during times of peace and war. I don't know what the fuck that could possibly mean. Jeez, useless. Totally agree about the no curves, just lots of little Planck straight bits. Yeah, well, straight paths anyway. I don't know what the bits are, but the paths they travel are straight. There are no once you get to the force level, there are no forces moving the forces. So the force bits can't do anything but do that straight line crap. They just can't be bent anywhere. Glad to hear you now see force bits as not frisbees regarding polarization. I don't know why it would matter, but yeah, it does simplify things just to say who cares what shape they are. Because I mean, I like not having to worry about it. I like not having to explain polarization with an actual polarization of the little bits, because it was kind of annoying, because it was a little hard to explain how the first bit and the second bit of a array would both be affected the same exact way, and lots of things were hard to explain. So I like the newer version better. Again, I'm not saying I'm 100% sure that's what polarization is, but it makes a hell of a lot of sense why the bigger the frequency, the longer the polarization. The more they're out of alignment. So there seems to be a strict connection between how close something is and how much it can be out of alignment. I mean, how close the frequency is, how small the period is, and how much alignment it can be out of. And so that's another reason to say, oh, that makes so much sense. I'm surprised I didn't think about it much earlier, because it's just it's an obvious factor that no one considers, is that alignment issue. It just seems kind of obvious. Variable properties, but surely red and blue are variable properties. Again, they're just metaphors. I don't know why you think red and blue are real properties. I'm not arguing that the things are red and they're blue. The point is they have a distinctive difference that a proton can tell the difference between them. A proton can tell the difference between the red force and the blue force. It doesn't do it by saying, oh, that one's red and that one's blue. It's because they're shaped different, they're a different size, there's something about them that means electrons know the difference between a black and a red, and the proton knows the difference between a black and a red. But that's it. It's just an identifier for a property the force has. Plus is different than minus. The South Pole stuff is different than the North Pole stuff. There's a difference. I don't know exactly what the difference is. It's a difference. Shit. Anyway, 90-degree deflections and 100 deflections are variable properties. That is not reasonable. Is that not reasonable? I don't know how they're variable properties. I'm just saying, yes, this is how the universe works, right? There's 4 rules, 3 rules, 2 rules. The rule is this red stuff can't interact with the black stuff unless it goes into matter. So the idea is this stuff travels on different planes of the universe. So the black squares and the red squares don't intersect on the checkerboard. There's no intersecting. And the only place they can intersect, the only place they can interfere with each other, is inside of a matter bit. So that's the difference. Somehow the matter bit pulls those 2 dimensions together and allows these 2 things to interact. But the only way they can interact really is to hit head-on or hit perpendicularly. And that's it. But that's the rules. There. Is that too much? No. But there's no variable properties. I just don't even know the way you wrote this. Variable properties. The properties don't vary. So when I was using the word variables and properties, the 2 words are separate words. I don't say variable properties. Where did I ever say variable properties? Matter bit is that fundamentally different from force bit? Yeah, well, obviously, I don't know. Look, you want to go all the way back to the beginning, huh? Well, I have the link below here where you go to the overview videos. But I mean, I've pointed out, this is like, I mean, I don't know how you've missed it, but I've pointed this out 7 million times. There's 2 kinds of forces moving the speed of light, red and black, and it accounts for all the forces: gravity, magnetism, photons, everything. Photons are just this black force, the electron force, at a frequency. Gravity is the mixture of forces, and magnetism is the segregation of the forces. That is the making some of them all go out one way and the other ones go out all the other way. Now, constituent to the two force bit types, there's two matter bits, electron and proton. That's it. That's all there is. Neutrons are just an electron and proton very close together. But that's all there are. There's electrons and there's protons. Those are the matter bits, not moving the speed of light. And they react to the force bits in exact opposite ways. If a black force bit hits a proton, a red proton, it leaves perpendicularly. If it hits a black electron, it reflects 180 degrees and the electron moves. And vice versa for the proton. That's it. That's the whole theory. The whole function. God damn. Yoop did say variable properties. I don't know. Did anybody hear me say or in any context imply that properties are variable or that variables are properties? Did anyone hear me do any of that? Would anybody say a summation of what I was talking about is something called variable properties? Did I imply that something morphs or changes and has variable properties, that electrons become protons or electrons become muons or duons or puons? Did I do any of that? So can anybody acknowledge somewhere that I actually did that in any way? Because I didn't, asshole. Where did I learn this? I spent 7 years figuring it out. I didn't learn it somewhere. I discovered it by saying, oh, this fucking two-slit shit is nonsense. This Copenhagen new universe, it's all bullshit. There's got to be a better answer. And so I went looking for a better answer. And I started with gravity, and then I ended up tripping over the secret of magnetism. And then I figured out the nuclear force. I mean, it all just fell into place. The truth isn't that elusive. It's just that they've been talking so much bullshit for so long, they forgot how to speak English. They forgot how to think logically. Physicists, they're just lost in their bullshit. Yes, the lectures definitely helped. I mean, I had to watch quite a few lectures to get my head around certain resonances, and there's lots of these wave concepts that I had to make these distinctions between things that are really waving mediums and things coming at a frequency that aren't a wave. They're just things at a frequency, for fuck's sake. And I had to know the difference between on-off patterns and interference patterns. Realize that no, nothing needs to be an interference pattern. Please don't get me wrong, Gary. I'm keen on your particle model, just trying the bottom of nature. Just trying to. That's not going to work. Just trying to the bottom of nature. I'm not going to make sense out of that. No points for the second part of that sentence. If you watch the reply, you did say variable properties. I don't know what you're talking about. You can't give that a little bit of fucking goddamn context. Where did I say something like variable properties? What was the context that I said the words variable properties next to each other? Clearly, I'm not arguing that anything has variable properties. Where in any of my theory have I talked about anything having a variable property? It's obviously not something I say or advocate. So why do you keep saying I'm implying it or stating it or any of this crap? You can't type the whole sentence I said where the word variable properties came out of my mouth, because it's clearly not a sentence I can imagine at the moment. Fucking Jesus. People just, I don't know why you hang on this crap. Just trying to get to the bottom of nature. Well, that's a little better. Bear in mind that YouTube restricts comments to 200 characters. Well, I mean, it doesn't restrict you from fulfilling my purpose here. I'm just saying, I asked the audience if they can understand it. I don't understand what you're talking about, okay? You're telling me I said something. I'm saying bullshit because I don't know what the fuck, what context I said it. Now, maybe I said winky, tinky, binky, binky. I don't remember saying that because it sounds like something way too silly for me to say. But maybe there is some context where I might have said that some previous time in my existence, but it doesn't seem likely. And I'm just telling you with all sincerity, I don't know exactly what context I said it, but I clearly didn't say it as variable properties, the principle. I certainly didn't say that. Variable properties, something I truly believe in. I didn't say that. I know that for fucking certain. So I don't know what you're arguing. What context did I say anything has a variable property? Fuck. I mean, it's clearly not my theory. Can I express my dissatisfaction for what you're saying I said, right? So I'm just going with your interpretation of what I said. But, this is just bullshit. I'm probably pointing out that maybe it was in the argument about pinball spinning or something, that creates a variable property, that you can't have a property, it creates if you have something spinning, you can hit it with more or less friction. You can do lots of things to take a little bit of the spin off or all of the spin off. It creates too much variety in the interaction. There's no evidence that photons have variable properties. That is, properties that aren't quantized properties. It looks like photons are all the same and they all do the same fucking thing. And there's no real evidence of any variable property. That's what I was talking about, I think, maybe. But clearly I'm indicating an opposition to variable properties. It's like electrons the spin doesn't even make much sense for an electron because you'd have to make it a quantized spin. You'd have to give it a complete interaction, like all the spin is exchanged or none of the spin is exchanged. As soon as you create like a little partial, then you can have like the idea of a photon rubbing up against something. Do you think that really happens? Like a photon loses a little bit of its spin and tells the electron, I went by you and I gave you a little tiny bit of my spin energy. Photons don't do that. So that's what I was saying. So I was clearly opposing the idea of variable properties, not supporting the idea of them. All right. Red photons and blue photons. You describe these as polarization. No, I don't. Oh, man. I mean, what, about 3 years ago, at least? Where have I done that recently? I've just said that could be. I've said, look, the difference could be the orientation, direction, some sort of orientation. It could be the shape, pointing this way, a triangle versus a pyramid, or a diamond or something. Let's see what else. I'm saying it's the difference like a square peg and a round hole. Okay, it could be the difference like round and square. I mean, you're obviously just somebody who wants to worry about semantics. Okay, I mean, wasting 2 comments. Now you're going to sit there and worry about this idea. I've made it clear to you. Red and blue is just a metaphor for a fucking difference. Whether the difference is the orientation, the polarization, some other fucking shape thing, it doesn't fucking matter. Oh, you're just an idiot. I've told you before, the photons can't have the difference in the shape because they're the electron force. So it's obviously not a variable property the photon can have, because the photon is always, always, always pushing electrons. It doesn't affect a goddamn proton except to do the, opposite of a reflection. So it doesn't have no impact on a proton, but it's not the proton force. So they're always black. Okay. The electromagnetic spectrum is always electron energy. It's always black energy at a frequency. Fuckhead. So again, he thinks the 90-degree thing and the 180-degree thing is a property of the photon, when I've been over and over again. It's a property of the fucking material bit. That decides how the photon, whether the thing reflects or whether it doesn't reflect, whether it goes out perpendicularly, is decided by the electron and decided by the proton. Whatever you're trying to do, I'm just saying you're obviously an anal lunatic. I'm sorry you don't think it doesn't matter. So you obviously can't, No, I think it doesn't matter. Not that I don't think it, I do think it doesn't matter. I'm saying, what do you want me to do? I mean, again, you think I have magical insight, and I can see so deeply into the universe that I know what is the distinctive factor between what causes the south pole of a magnet and the north pole to have emanating from it a force that has a difference, and I can see the difference in the force. I can't just know that, yes, they're different forces. They have something about them that's different, electron force for proton force. I'm supposed to give you the explanation for exactly what the difference is. The smallest bits in the universe, and I'm supposed to tell you what that shape is. Conventional physics can't even tell you they exist. They call them virtual photons. They can't even figure out where they come from. They call them bent space. They have it so fucking wrong. And you're harassing me for this fucking detail of information that, yes, in fact, can't possibly matter. If the answer is one's square and one's round, is that meaningful to you? Wow, that's so profound. I can't believe it. One's a hyperboloid and one's a toroid. There. Are you happy I used a silly word now? A Ken Wheeler word. Fuck. People just don't get the point. My only obligation here is to provide a more detailed and more complete and more consistent with the evidence explanation than current physics. The questions they don't even come close to answering. Not that you can ask me, but you can't badger me for answers to questions nobody has answers to. Shit. I can't tell you where the first photon came from. Yes, I've already said that, but I can explain magnets and electricity without describing the exact shape of a photon. You don't need to do it. You don't need to know what a positive is and a negative is. All you need to know is the two are different and they have certain properties because of those differences. You don't need to know why, in the sense of what it exactly is. The exact, like I said, if I tell you the answer, okay, the answer is electron forces square cubes and proton forces round balls. There, that's the answer. Now, how does that change anything? And the proton, obviously, when a square comes in, it has a square trap, square hole. And if it fits in the square hole, it it means the force going this way will also fit in the square hole, so the two forces can hit each other and the squares will pop out. But if it's round, can't get through the square hole, can't hit the other square, nothing happens. Well, no, it can, but so now it goes perpendicularly. So then it can only use the round traps, which allow this kind of, the round traps allow crisscross, but they don't allow direct reflections. So they only allow crisscross. There. Are you happy? I don't think how you're, I don't see how you're doing this, whatever. You're just trying to apply your excellent critique to explain the fundamentals. I just don't know. They're fundamentals for which you should have no expectation that I have the answer. No expectation. I can't know of evidence that doesn't exist. I'm just saying there's no. The best evidence conventional physics has, they have to call them virtual photons. You get it? They're so clueless. That's the best evidence. All their evidence indicates to them, I don't know, they're virtual things. I don't know. They can't even come close to identifying them in any way besides just calling them photons. So I'm saying there's kind of obvious that there's no evidence anywhere, of shape, what makes them different. And it doesn't even have to be shape. Like I said, it could be mass, could be, who knows what it is. It's a difference that matters. But that's it. I mean, they're rhinoceroses and hummingbirds. Rhinoceroses know, their kids, and hummingbirds know their kids. And, so I don't know what to say. Never mind. I like you to have the answer. Well, whatever. You just did this, whatever this is. I'm just sick of it. I'm just trying to encourage you to aim for the absolute answer. Well, I'm just saying, I can't imagine how it's useful information. Can't even imagine why you would think it would be useful information, why it would be at all interesting. It's not going to be the difference is one's a magical hopping unicorn and the red force is, a four-headed pixie. That's not going to be the answer. I mean, the answer is going to be just mundane and totally useless as information. It will not make it all make sense. It won't fill in any gaps. It just won't do any of that. It'll just be a mechanical device that filters. I mean, it's like that. Do you think a filter paper, you need to know exactly how the filter paper filters? you know, and if you don't have every detail of every, you know, uh, flow dynamic of the static charge that pulls the little tiny water molecules along the threads or something, if you don't know every detail about how that works, you're just feeling totally empty and unsatisfied. I guess that's the difference between us because I've never had that much curiosity. I just want to know, yeah, filters. I get it. I get it. So anyway, anything seems to be slowed down. I don't see any more comments or anything other relevant or meaningful. Blah, 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 blah. Let's see. We know that electromagnetic effects demonstrate the 9-degree thing. Yes, I want to understand that as a curious human. Well, look, I'd like all those answers too. And have I not displayed to you in these diagrams the very fact that I'm working on it, in the sense of working on mechanisms that would reduce the universe to even smaller little bits of energy. And I just said that in this video. I think the real universe is just a bunch of locations with a bias in a direction, and that's all it is. And all you're doing is rearranging the colors of those little bits, and that changes their bias. Obviously, if you make there's 2 bits, and you make the red one go this way and the black one do this, then obviously you've changed the bias of the circumstance. You've completely changed the universe in a way where if they were all black, you wouldn't be able to see the difference. So clearly, this fundamental difference between the red force and the black force, or the proton and the electron, their fundamental difference is everything in the universe. But again, red and blue does it for me, or red and black. I don't think we're ever going to get the mechanism. It's like, okay, it's like the argument for creating the on-off pattern, right? On, off, on, off, on, off, on, off. There's so many ways you can do it that I don't think you could ever just say, oh, I've narrowed it down to this cause for on, off, on, off, on, off. It's a wheel, and there's a little lump on the wheel, and it's causing the on, off, on, off, on, off. You're never going to, I don't think you're ever going to be able to get enough information to be able to figure out which one of all the available options for the cause is the only cause, the right cause. Anyway, yes, Gary, we are working on it. I'm just trying to encourage your inquiry. Well, you're not. Does this sound like an encouraging conversation? This belligerent anal crap about stuff I shouldn't even be wasting my neurons on, because I'm really not going to be able to give you the answer. I'm really not. There's so little chance that all I have is evidence of this on-off pattern. And I know there's 6 million ways to create an on-off pattern, and I'm supposed to choose which one is the cause. And I'm saying I'm never going to have enough evidence. There's not enough detail in the on-off to tell me who threw it. It's like saying I could take an image of a pitcher's pitch, and then I could ask you. I could say, go find the pitcher that threw it, and the chances of you having enough detail in that image to be able to tell who threw it, not much chance. Well, again, I just don't think it's a meaningful. You keep talking like this is meaningful, and I just don't think it's meaningful. It'd be very nice to show everything, but it's never going to happen. You're never going to get this little perfect videotape of the evolution of the universe. So let's see what this is. Okay, so it is also misleading when you say the universe is expanding. So again, I don't know why you imply that I've ever said I am certain the universe is expanding. I've said exactly the opposite in a sense. I've said the only reason why they think so is redshift, and I said there's lots of causes for redshift, potentially, that we don't even know what happens when you move something very fast this way into your field of view, because technically it's closer here than it was over here. So technically, something moving away from you sideways could also be redshifted. I've said those very words. Let's see. Do you mean everything is just moving fast apart? Again, I have no interest in whatever this mush is, but not that much is changing as in new stars and planets. I said galaxies are expanding, not the universe. I said galaxies start off as a condensation, like a black hole or something, but I don't think it has to be black. It's just not on fire. It's a bunch of matter compressed into a giant thing. It doesn't have to be tiny little grapefruit or anything. And the galaxy is formed by that breaking. And the first part of the breaking, I think galaxies are always binary, their core. So it's always binary. Two big hunks of mass moving around each other. And that's what's creating the arms. And yeah, and so as they age, they expand because more and more energy comes out of the center of the galaxy in the form of these stars. But that's, yeah, I think that's how galaxies work. I don't think they're getting smaller, they're getting bigger. They're not collecting matter, they're releasing it. All right. Do they, but I'll say again, I'm really not terribly interested in cosmology. My bigger interest is in the small universe, because that's the only universe. you know, and the reason why I'm interested in things like bending light with gravity waves is just because light is in the small universe. Do they mean everything is just moving? Okay, so now you say they, so that's good. Okay, so it is also misleading when they say, okay, sorry, my mistake. All right. When they say the universe is expanding, do they mean everything is just moving further apart? Well, what they mean is more space is being created everywhere. Now they don't concede that more space is being created inside of this pen, inside the atoms, but they're basically arguing that everywhere else more space is just popping into existence, and so everything's being pushed by the more space being popped into existence. That's why they call it like dark energy. It's like some idea of push that pops into little places in the universe. Little push balloons pop, and everything gets pushed bigger and bigger. The filling balloon argument. The balloon doesn't stretch in one place. All the little particles on the balloon are stretched. Okay. Part, but not that much is changing as the new stars and planets. ... Yeah, I don't know what you're going with that. Obviously, things change if you move them apart because gravity don't work too good at a distance. So it's obviously undoing the. It's obviously undoing gravity, but momentum is undoing gravity. I mean, they've never really accounted for the momentum of all the material bits in the universe. And I could play the NASA video now. Maybe that'd be, I don't know. I don't really want to get into that. But it's another one of these things where they talk about orbits and the bent space thing. And they never talk about them accurately in the sense that orbits are a really hard place to get to. And when two things move towards each other in real space, the fact is they'll always crash into each other because the gravitational influence takes quite a bit of time. So the thing is moving and it's going to just bend, and then it's going to go accelerate right into the center. So the majority of stuff that goes into a gravitational field, unless it's moving really fast, is going to get pulled right into the sun and crash into it. And it's only something has to interact before it hits the center. It has to hit something and get deflected. And that's the only way the Earth ever got into its orbit, is that it either had to come from this, it had to be a byproduct of something inside the solar system, or if it came from outside the solar system, it had to hit something to end up in a stable orbit. And that's how gravity really works. And they keep just showing it in this fake way. They never really explain how you can't push something into the gravitational well. If I just drop something on the edge of a gravity well without any momentum, you'll clearly understand how it'll just fall right into the center. It won't miss the center. It'll fall right into the center. And for most things, they're going to be coming from a distance. And so the gravity is pulling on them little bit. So there's lots of time for the gravity to bend the path. And so it's not like it's not like pushing a ball into this huge well, because there is no steep edge on the well in the sense that it's a gradual edge on the well. But anyway. Okay, just taking the two-slit experiment, period. Not sure if you have dealt with the depth of the slit itself. Well, I mean, I've talked about it in just the video 2 days ago. I made a whole list of all the crap that needs to be done, the experiments that need to be done. And right on the top of the list, okay, is the word thickness. Okay, and then there's materials, metals versus plastic versus, and then there's magnetize the slit and see what happens. Then there's do the experiment in a vacuum and see what happens. And then there's electric charge and see what happens. And then there's reflective versus opaque, black versus a reflective surface and see what happens. A black needle versus a chrome needle, for example. I mean, just a simple version of the single slit. You don't need to do the double slit to see most of these effects. But anyway, yeah, they haven't done any of those experiments, right? That's the joke here. No careful, what's the right word I want to use? No careful experiment has been done changing these variables. This is their most famous experiment, the foundation of their quantum mechanics, and they haven't bothered to test any of this shit. Amazing. All right, have you dealt with the depth of the slit itself, thickness of the wall sheet the slit is in? Well, what we know from other experiments is that if I make a tube or something else, that I will destroy, terminate, collapse the wave function of photons the thicker I make the material. So some of the photons will get pulled right into the material and you won't ever see them leave. So that's what thickness does. Thickness destroys some of your photons. That's one effect that's interesting, right? Clearly, because that means there's more of a reflection, right? That means it's the thicker you make it, you could sort of argue that if you have a lot of, like if it's the photon that's supposed to go way over there, well, if it starts going way over there before it's gotten out of the slit, it's going to go into the material, right? So clearly how thick you make the material should kill some of the photons by my theory. So that's perfectly consistent anyway. But yeah, no, it'd be nice if they had a bunch of experiments doing this incrementally thicker slit and see exactly how it changes the pattern. It'd be very nice if physics actually did some interesting experiments instead of, spending billions of dollars on gravity waves. Bullshit, technology that no one should have an expectation that this crap actually works. Okay. Gary, you did a brilliant critique on the pi equals 4 crap. Well, that was kind of turned out to be even easier than I thought, because at first I thought he was actually using a rational formula. When I realized he was just using the formula for the conversion of arc seconds into degrees, it became even more ludicrous. I trust you see he never uploaded the promised second video, the one that didn't quite agree with pi equals 4. Yeah, well, I see that, and the other guy who did the experiment, the one who did the little toy thing, I see he didn't make any updates either. He was supposed to make an update, and that never happened. So maybe he figured out that, yeah, this doesn't really apply to gravity. Running a ball bearing in a fucking plastic tube ain't exactly how gravity works. But I think my explanation was kind of unique in the sense that no one really talks about it in that sense, you know, that the energy when you force something to turn, right? If you don't have anything that's accelerating, that's pushing, and it's just friction you're relying on, then all the energy has to come from the thing that's moving. So if it's going to turn, all the energy has to come out of it. So it has to slow down to turn. That I thought was a pretty good little insight. So like racetracks use gravity because gravity's an active force. So the car can maintain its speed going around the turn because now you're letting gravity do the push it down thing, push it into the curve. The gravity, an active force, is instead of the wall or the friction on the road, you're letting gravity, an active force, do the pushing. So now the car doesn't have to. All right, Gary, is it fair to say that for explaining gravity, force bits can all be one color? No, if you're going to explain gravity accurately, you have to recognize that it's really a magnetic event. It's just that it's there's no polarization. But the idea of absorbing the energy has to be done through the same rules of the fact that you're a lot of the energy is taking a lot of paths. Okay, I mean, if the black energy hits a proton, it goes this way, right? And then it can go this way, it can go this way, this way, this way, this way. It can go out. It can do. There's different probabilities for all that stuff. So I'm saying it's not exactly all right. For the sake of the argument, you can clearly explain gravity without going into the detail of exactly how all the force turns into how it's converted, because all you really need to understand is the force has to be trapped. That is, the energy has to be collected. The momentum, as I drew in the other drawing, the momentum has to be collected that forces the object to do the little bulge thing, you know, where it constantly maintains this prejudice in a direction. Let's see how else to say that. Well, anyway, I guess I don't want to. I don't want to agree that you're being. I don't see any point in oversimplifying when you don't need to. So I guess that's all I want to say there. I just don't want to say, oh yeah, you can disregard color or type when you're doing gravity. You really probably shouldn't. You're not being accurate. I'm just saying you can do the generalization, the simplification, and not worry about it and get the right answer. But I'm saying if you really want to get the complete answer, you have to do it where you do the fact that it is a magnetic event. You said all energy has to come out of it to turn. Yes, the momentum that the the ball bearing, if it's going around a solid curve, all of the energy to turn it has to come from the ball bearing. That's why it has to slow down. It has to give away energy to create push in the curved direction. And that's exactly what friction does. Let's see. That was my point about the 90-degree proton turn with an electron. Yeah, and it's exactly the point I was making, is that the 90-degree turn in the proton It's not, well, even if it's a 90-degree turn in the electron, it wouldn't matter. The point is, though, is that the energy is the force inside the electron is doing the interacting. So it's not, it has its own energy. So you're thinking that there's only one pushing force. No, the electron is pushing out and the force pushes in. So when there's a reflection, there's force pushing out and there's force coming in. So there's two reflections, not one. And so you're not accounting for the fact that it's exactly what I'm saying. It's like with gravity. The Earth is being pushed by the gravity. That makes it turn. So the Earth doesn't have to slow down to turn because this force is doing the turning. This is providing the energy. The external force provides the energy for the turn. Oh, Jesus. Sorry, Gary. YouTube is dropping out occasionally and I'm missing your answers. Well, tough. Watch the video later. Sorry, Gary. I wrote photon, not proton. Well, I don't know what you were talking about then. But again, I've told you, I've said it a million times. Protons don't do shit. They're going a straight line. So I don't know what you're talking about then. All right. You said all the energy that has to come out of it to turn. That was my point about the 9-degree photon turn within an electron. And as I've pointed out, it's not turning without an external force. The force is, I said it pretty clearly, this collides with this. This goes this way, this goes this way. This is a force. So this doesn't just turn. I just turned. Yeah, that would take this's energy to turn. This turns it. Anyway, you really do have to. I don't know what your name is anyway. Diamond NZ. Mundi? Mani. I don't know. I don't know what that is. You should call yourself Anal Much. No offense, really. I appreciate the comments and all that stuff, but yeah, it just does drive me insane when people want me to answer questions that I don't think are really pertinent to the objective here. Anyway, past my bedtime and such. More than enough, I think. And appears to be done with commenting, so I think we're done. Yeah, I'm probably over 2 hours, probably. Let's see. Oh dear, that's more of this mum stuff. We don't want to deal with no mums. Gary, your mom named you Gary. Yes, well, my name is because I have a twin sister. So I was either going to be Jack and she was going to be Jill, or it's going to be Gary and Gail, or it would have been Steve and Stevie. I don't know. I don't know what the other, names are, but obviously we just got named to be, cartoon characters. That's all. I was named for the purpose of creating good twin name. Anyway, dear Mid. Okay, well, you really got to show your mother. I mean, my mother should have been shot also, but yes, your mother should get the first bullet because that's really retarded. What was she thinking? Diarmid. Why would somebody name somebody Diarmid in an unpronounceable way? I mean, spelled in an impronounceable way. That's just so funny. I mean, I suppose I don't want to insult anybody's culture or something. Maybe she was from, Sylvania, some kind of weirdo country. But it is funny. So, yeah, sorry. No offense. Didn't mean to insult your heritage. What does it mean in Latin, right? He who has big anus, or he who keeps his eye on the anus. Yeah, that's probably what it means. I think my name means like spear chucker or something. He who throws spears or something. And that turned out to be kind of funny, like true, right? I am kind of a fucking arrow thrower. It's quite funny. So anyway, coincidences, charming. Anyway, I think yes, probably enough. So till next time and such, and so forth and whatnot. Been a real run of these. I've really gotten into a habit of kind. I don't know whether that's a good or bad thing, but it does seem to be a habit. Only 10 viewers. That's pretty poor. So yeah, I'm not winning anybody over, but time will tell. And such. Oh, what will I do first? Oh, that's right. I'll close the thing first, and then I'll restore the chat just to make sure it doesn't get killed in some stupid way. All right. So till next time. Thanks and such.